stands for congruent parts of congruent triangles are congruent. Our EQ. If you know that two figures are congruent, what can you conclude about corresponding sides and corresponding angles? Our learning goal is to use CPCTC to prove parts of triangles are congruent, and you guessed it, our key term is CPCTC. Speaking of CPCTC, what is it? It's just an abbreviation, guys. It's an abbreviation for the phrase corresponding parts of congruent triangles are congruent. Okay? It can be used as a justification in a proof after you have proven two triangles are congruent. After. Not before.
During.
Not during. Not almost close to the end. No. After. So you're going to use CPCTC after you use one of your 5 triangle congruency theorems. I'm moving on. So, guys, just keep this in mind. I use CPCTC after I've proven triangles are congruent. All right, let's take a look at it. No, don't write it. Just look. A and B are on the edges of a ravine. Ooh. What is A to B? Well, first we got to think about this.
18.
Yeah, that's great. It's 18. It is. It's 18. And that answer will give you about 25% credit. Because you've got to write the full answer to get full credit. Here's our full answer. Let's just call this point X. Let's call this point C. And we'll call that Y. Sure. Okay, check it out. Step 1. AX is congruent to YX, right? Because they're both 10. Step 2. BX is congruent to CX. Why? They're both what? They're both how much? 15. Thank you. Okay. Why are these angles congruent to each other? Vertical angles are congruent. How is triangle AXB congruent to triangle YXC? What theorem? Okay. Side, angle, side. Correct? Side, included angle, side over here. Side, included angle, side over here. That's everything we've done to this point. The only thing we are now concluding. Okay, let me back up. SAS is used, SAS. It's used to tell me what? What information does that tell me? Who said what? Yep, says the angles between the two sides are congruent, but when do I use something like side angle side?
When you have two sides in it.
When the what? Y'all are thinking very small term. Think bigger picture. Go one step bigger than that. What does that tell me? What does that give me? What's congruent? The triangles are congruent, right? Side angle side tells me that triangle AXB is congruent to triangle YXC. Okay? And once these triangles are congruent, I know that AB is congruent to CY. So AB is congruent to CY because corresponding parts of congruent triangles are congruent. CPCTC. So if this is 18, how much is AB?
18.
That's why you only get about 25% if you just put 18. You have to have the full explanation. go through this one. Same rationale. KL is congruent to LM, right? There's sides. JL is congruent to NL. There's another pair of sides. What do I know about these two angles? They are vertical angles, and vertical angles are congruent. Are two triangles congruent here? Because of what? Side angle side, right? Once I get side angle side, that means I get congruent triangles. Using congruent triangles is how I can conclude that all the remaining corresponding sides and angles are congruent to each other. Now I'm just marking up stuff. Okay? So CPCTC, think about this. Guys, we started a couple, beginning of the year, several weeks ago now, okay? And I said, in two different polygons, for those polygons to be congruent, all the sides and all the angles have to be congruent, right? All the corresponding sides, all the corresponding angles have to be congruent. And then I came to you and I was like, oh, but with triangles, we got 5 shortcuts. Side, 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 angle, side, angle, angle, side, hypotenuse, leg, right? Okay? Well, guess what? All the corresponding sides and corresponding angles still need to be congruent, okay? And CPCTC takes care of all of that. Okay? So it minimizes, if you will, the amount of work you have to do in your proofs. Take this for example. YW bisects XZ, XY is congruent to YZ. Prove that angle XYW is congruent to angle ZYW. Get to it. These two are congruent because it tells me they're congruent. A bisector splits a segment into 2 congruent segments, correct? How is YW congruent to itself? All over it. YW is congruent to YW because of the reflexive property. Okay. How are these two triangles congruent? How is triangle XWY congruent to triangle ZWY? Side, side, side. Okay. So triangle XWY is congruent to triangle ZWY because of side, side, side. Well, do I have congruent triangles? What's true about the what's true about the corresponding parts of congruent triangles? The corresponding parts of congruent triangles are congruent, right? Is XYW corresponding with ZYW? Yeah, they are. So angle XYW is congruent to angle ZYW because C, P, C, T, C. Corresponding parts of congruent triangles are congruent. Any questions on that? It's a big proof day today. About here. I'm given that NO is parallel to MP and that angle N congruent to angle P. Oh, angle side side.
Angle side.
Well, that work? Ever? I tell you what.
Well,
Vo. Well, angle at the beginning of class in the warm up. No, who was it? I didn't ask you. I asked Brady. Brady. Beginning of class in the warm up. You answered this question. Can angle side side be used to prove that two triangles are congruent? You said no. What do you say now? No, it's still no. It's never going to be yes. Okay? I'll just give you the preview. It's always no. Okay? But what these parallel sides do tell me, when they are cut by a transversal is that the alternate interior angles are congruent. Okay? They are congruent. Well, Miss Sutton. Yes, ma'am. How is MO congruent to itself? How is MO here, this MO, in triangle MNO congruent to how is, let me back up. Side MO in triangle MNO is congruent to side MO in triangle OPM. How? Yeah, it's a whole bunch of horse honking. Whenever you see something is congruent to itself, you automatically say reflexive property. Okay? Every time, guys. Just go with your good old friend, the reflexive property. Okay? If these sides are congruent, I have two angles and a non-included side. What theorem am I going to use? Angle, wait, side, angle, angle?
No, angle side.
Angle, side, angle, because the side is between the two angles.
Yeah. What? No.
Angle, angle, side, angle, angle, side.
I must wait the
Okay. Triangle, let's call it MNO, is congruent to triangle OPM through angle, angle, side. If triangle MNO is congruent to triangle OPM, what does that mean about the corresponding sides and angles? They're congruent. How do you know? No.
Oh, what's the means?
CPCTC.
Oh, yeah, that
You just answered it when you answered my question. How do I know that corresponding angles and sides of congruent triangles are congruent? Because the theorem, corresponding parts of congruent sides are congruent, tells me that. Okay?
513.
So that means that angle O is congruent to angle M, right here. And I can use that to tell me if these alternate angles are congruent, then the sides that make them are parallel. So far, which is good. And if you want to see it as a two-column proof, look at here. Because this is what you're going to be doing.
So is it always going to be the C thing?
CPCTC
Yeah.
is going to be used every time today. Okay? What do we always start with? The what? The given. Okay? They said alternate interior angles. NOM is congruent to PMO. NOM congruent to PMO. Yep, they're alternate interior angles, and alternate interior angles are congruent. Through the reflexive property, MO is congruent to itself. Once I've established that, I can conclude through angle, angle, side, triangle MNO is congruent to triangle OPM. After I've proven two triangles are congruent, I can use CPCTC to tell me that the corresponding sides and angles are congruent. I get that last step's maybe a little bit farther than we'll get today. The converse of the alternate interior angle theorem is how I know that if alternate interior angles are congruent, then the sides that create them are parallel. Okay? Guys, here's what I really want you to know or get out of today. One of the things. There's another one coming up. Here's one of the things. Where is this in relation to this? After. After. Not before. Not at the same time. Not really, really, really close, but not quite. Always after. Okay? You are dead wrong if you try and put CPCTC before any of your 5 triangle congruence theorems, right? It needs to make logical sense. I'll use a few examples. When is the only time I can put my belt on? After I put my pants completely on, right? When, if I have to wear, think about it like this, if I have to wear socks underneath shoes, when can I put my shoes on? After you put socks on, right? But you don't have to wear socks, but you gotta wear socks in this case. That's fine, you can be weird, alright? When do you put the jelly on a peanut butter and jelly sandwich? You are so weird, and that's wrong. That's the difference. I can't think of anything. I tried to say this in first talk, and apparently I'm wrong, but I don't. First time heard. Alright, when do you put conditioner on? See, some people, I don't have this problem. I don't know. I don't get to use any of it. So
Conditioner where you put conditioner on bib I do shampoo.
stop. Alright. Here's the big takeaway, guys. You cannot use CPCTC until you've proven that two triangles are congruent. Got me? It's a lot. It has to come in that order. Everybody with me on that? Don't mess it up today. Okay? Alright. You get a 4-minute break right now. Give you a 4-minute break. If I'm given that triangles DEF and GHI are plotted at these points that it shows you, -5, -5, -3, -1, -2, -3, -2, 1, 0, 5, 1, 3. How do I prove those triangles are congruent? Yeah, what's the problem with this? I don't have any, what?
Use the,
Oh my gosh! My golly! We gotta use the distance formula.
Oh, God.
Okay? Look at your formula sheets, those blue things that are on your desks. That's not my fault, that's y'all's fault. You're right, it's not all of your faults. It's just some of your faults. If you have two, please share with a neighbor. If you don't have any, I'll have to get you one. Alright? Alright, they should be on the floor. Usually they end up on the floor, like here.
Why didn't you tape them to the desk?
Oh, because then kids would just untape them. I've done this a couple of years. Alright, so, here's what I have to do, guys. My distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Brr? Talk about how we put all these numbers in here. Okay? To use the distance formula, you need to find two coordinate points. Label one of them point 1, one of them point 2. Because whenever I put my formula, whenever I put my coordinates into the distance formula, I'm going to be finding out how far it is from each point. Let's do it easy. Let's do D to F. Okay? Let's figure out D and F. How far is it from D to F? 3. Well, math will work. We got to do some math, right? Here's how we do it. The coordinates for D are -5, -5. The coordinates for F are -2, -3. Mr. Hobbs, there's negatives in there. Yes, I'm aware. I'll teach you that. Which one of these do you want to be point 1? D becomes point 1. So here is x1, that's 1. x1, y1. Everybody got me?
Yeah.
Because we write these xy. Which means F has to be x2 and y2. Simple so far, right? All you've done is write down the coordinates and label one of them points 1 and one of them points 2. Here comes the hard part, making sure you put these into the distance formula correctly. Distance is x2, which was negative 2. Oh, and then we get this. Minus negative 5. Alright, and that's where the first mistake usually occurs. Yeah, minus negative is not recognized in your calculator because we don't talk in math speak saying minus negative. Right? Don't go around to my little niece's birthday and say, hey, next year are you going to be negative 3 minus negative 2?
I'm gonna do that.
No, we don't do that, right? Okay? We say plus. Whenever you get minus negative, you change it to plus. Okay? Don't forget that. Change minus negatives to pluses. Keep going with it. Plus, parentheses, y2, which is negative 3. Uh-oh, minus negative 5. What do I do to it?
Plus
Plus, not plus negative 5.
plus 5.
Got me?
Yeah.
That's the second common mistake. When you change minus negatives, you're going to say plus negative. No. Turn your frown upside down, my friend. Okay? Alright, last thing I'm going to show you how we put this into a calculator. Everybody get a calculator out and follow along with me, please.
That's it.
Hey, here we go. Alright, here we go. You put the square root button, which is right here. Square root. Oh, I'm sorry. Where's your calculator? Then you put in a left parentheses. Then you hit the negative button right here. Negative 2 plus 5. Then you put the right parentheses, and look at this. Here's the square button right there. Everybody got me? There's the square button. Square. Plus, left parentheses, negative 3 plus 5, right parentheses, squared. You hit equals. The square root of what? Square root of 13.
I was
Okay? So this whole thing equals the square root of 13, which means the distance from D to F is whatever in the heck the square root of 13 is, which I'll be honest with you. 3 point whatever. Keep it as the square root of 13 for now.
So it's still 3.
It's not 3. It's the square root of 13. If it was 3, it'd be the square root of 9.
The square root of 13 is 3.6.
Is that the same as 3?
Yeah, just with 6 extra.
Oh, I'm sorry. Let's try this again.
Never mind.
Is 1 the same as 1.1?
No.
No. Okay, we're done. Alright? Now, check it out. That's only one step. Technically speaking, you're going to have 6 of them, right? Because guess what? You have to do this for this side, and this side. And that just gets you one triangle. Then you'd have to do it for this side, and this side. Then you have 2 triangles. Now let's think about this. Guys, children, if we have, ladies, if we have 3 sides of one triangle and 3 sides of another triangle, what theorem might we be using here? Side, side, side. Right? Because there's no angles involved, and last I checked, this wasn't a right angle. Wasn't a right triangle. Side, side, side. I did the work for you on this one. This is how, hopefully, your proofs start flowing. Okay? That's a whole lot of distance formula. That's part 2 of today's lesson. We'll be doing the distance formula. Okay? It will become your friend. It will become easy, and you can do it in 30 seconds. It might not happen after today, but I promise, once you get the distance formula several times down, oh, don't shake your head at me. It'll become much easier. All right? Check it out. Here's what this triangle proved. DF was congruent to GI. DF congruent to GI. And then it proved that what? DE was congruent to GH. DE congruent to GH, and then HI was congruent to EF. Do I have congruent triangles? If I have congruent triangles, what's true about the corresponding angles? Because of what? If you get that much, you got the whole thing that you need for today. Okay? Really and truthfully, the distance formula problems I think are easier than the other ones because you're doing more tactical math skills, right? You're actually plugging in numbers, and then the only thing you can say is, well, the sides are congruent, so it's side, 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 and through CPCTC, the angles are congruent. Or you can say, the sides aren't congruent, so the triangles aren't congruent. The end. All right? Everybody with me on that? Any questions on that?
Go to sleep.
You may not go to sleep yet. You may get started on your classwork. It's